This is a good example of a double radical equation. When we have two radicals, in this case two square roots, we're going to need to approach this in multiple steps. The first step is to isolate and remove one radical, but we'll still be left with a radical with a square root. So after we've eliminated one square root, we'll go back and isolate the other remaining square root, square both sides to eliminate it, and then we're ready to solve for x. So you'll see the steps listed here. We're going to isolate one radical. That's already done for us. Do you see that this square root of 13x plus 16 is already isolated by itself? So we're done there. And now we're going to square both sides, and that's what you see down here below the problem. Be careful when we square both sides that you're squaring on the left side, that you're squaring that entire expression. It's not the square root of 7x plus 1 squared plus 3 squared. It's that whole quantity squared. So it's going to look like this. We'll have the square root of 7x plus 1 plus 3 times the square root of 7x plus 1 plus 3. And see how that is the binomial squared, not the term, each of the terms squared. That tends to be one of the first mistakes students will make, is they'll think that that's equivalent to squaring each piece, but we have to in fact square this entire thing together. So, sorry, let me go back and highlight that. We're squaring this whole term, the whole expression, the square root plus the constant times the square root plus the constant. Now, when we square the right side, that's squaring a square root, and the square of the square root, they undo each other, so we're left with a 13x plus 16. We're left with that radicand, with the 13x plus 16. So on the right, we're good, but we've got to still FOIL on the left. When I multiply those together, it's first times first. So I'd have square root of 7x plus 1 times the square root of 7x plus 1. So those square roots undo each other. Plus 3 times the square root of 7x plus 1 plus 3 times the square root. So I can just double the product of 3 times the square root of 7x plus 1. Plus 3 times 3, so plus that second term, the 3 squared. Next, I want to isolate this remaining square root. To do that, I'm going to need to subtract 7x and subtract 1 and subtract 9. I'm just going to write that as a subtract 10 because we're subtracting the 1 and subtracting the 9, right? Now when I do that, I'm going to transfer up here at the top so that we have plenty of space. We'd have a 6 times the square root of 7x plus 1. That's what remains on the left. Right, that's this, because everything else will have been eliminated now. And on the right, we'd have 13x minus 7x, 13x minus 7x, 13 minus 7 is 6, so we have 6x, and then 16 minus 1 minus 9, so 16 minus 10 would be plus 6. Next, as I continue to isolate the radical, it's going to be a little bit easier going forward if I can divide both sides by the 6. And since it does divide evenly, I'll go ahead and do that. So I'll divide both sides by 6, and I end up with the square root of 7x plus 1 is equal to 6x divided by 6 is x, plus 6 divided by 6 is 1. Now we are all set. We've isolated the second radical, and we're ready to square both sides again. When I square the square root, I get 7x plus 1, because that radical, the square root, and the square undo each other. And when I square the right side, x plus 1 times x plus 1, I'm going to get x squared plus x, so that's plus 2x, plus 1 squared, which is 1. Squared both sides, so now I'm down to the last step finally, right? Now I'm going to solve for x. This is a quadratic equation. It's a quadratic because, so when I solve for x, I'm going to recognize this is a quadratic equation because I have an x squared. So for a quadratic equation, remember that the process to solve that is going to be to set it equal to 0. So I'm going to subtract 7x, subtract 1, so that I can get a nice big 0 on one side of the equation. And I'd have x squared minus 5x left. And remember what to do next. I'm going to factor the x squared minus 5x and set those factors to 0. This is an easy factor because I'm simply going to factor out the GCF of x. Sometimes when we get to the step of factoring, because there's not a constant, sometimes it will throw a student off because you'll forget that, oh yeah, all I have to do is factor out the x. So don't be thrown off when we're left with a two-term expression there, a binomial. All we do is factor out the x. Now be really careful of this next step, because here's where we're going to solve for x. Remember, we set each of these two factors. The two factors are x, so we set the x to 0. We set each of the two factors to 0. And the other factor is the x minus 5, so we set the x minus 5 to 0. Sometimes a student will just ignore that x, but in this case we have the x equals 0 or x minus 5 equals 0. When we have x minus 5 equal to 0, we could solve that for x to get that x would equal 5. So it looks like we have two solutions, but don't count on it yet. Don't count on those two solutions yet. What we need to do, because this is a radical equation, we need to be sure that both of those answers are in fact solutions. So really important step here is to check. Really important in a square root equation that we check our solutions. Here's how we check it. We're going to go back to our original equation. 7x plus 1 square rooted plus 3 equals the square root of 13x plus 16. What I'm going to do is I'm going to replace that x with a 0 and see if that does in fact work out. The square root of 0 plus 1 is the square root of 1, which is 1. 1 plus 3 is 4. And the square root of 0 plus 16 is the square root of 16, and the square root of 16 is 4. So it looks like we're good with the 0. We can accept x equals 0 as a solution. Let's check the 5. So we have the square root of 7x plus 1 square rooted plus 3 equals 13x plus 16 square rooted, and we're checking to verify if I replace that x with a 5, is it still true? So what we have on our left is the square root of 35 plus 1, so that's the square root of 36 plus 3. The square root of 36 is 6, and 6 plus 3 is 9. On the other side, we'd have 13 times 5 is 65, plus 16 is 81. Square root of 81 is 9, so it looks like, yes, that one works also. So it looks like we can go ahead and accept both of the x's. So the solution is 0 or 5 would both solve this equation. I hope that this video has helped you understand this process a little bit more. It's not an easy process because it has so many steps and you have to keep going and keep going. If you make a little error with some of your algebra or arithmetic, lose a negative early on in the problem, you'll end up having to scrap all of your work and start over because it has so many steps. So be sure that you're doing each step really carefully. Check your work along the way as you go. Make sure that each step is correct before you move to the next step. And I think that once you practice this skill a few times, you'll find that it'll get easier and easier and you'll be an expert at solving double radical equations. But let me know if you have any further questions about this example, and thanks for making time to practice this important example.